optimization, we are going to be looking at word problems in this. So our steps, the things we need to do, is figure out what we want to maximize or minimize. We want that to be our x in our problems, our variable. We do not want problems that involve x's and y's, because if you have multiple variables, when you do the derivatives, you have to do implicit differentiation. Remember, like dy dx's and d dx and all that, and it gets really nasty. So you want to put everything in terms of one variable. If I say you have two numbers that add to 5, you don't want to say the numbers are x and y. If the numbers add to 5, then you could say the numbers are x and 5 minus x. Okay, so we want to keep everything in terms of one variable if we can. Then we have to kind of find a formula. So maybe if I were trying to maximize the product of that. Okay, so my numbers, the way it would be x and 5 minus x. If I wanted the product, what does that mean? Multiplication means you have to multiply them. So the product will be x times 5 minus x. So we make an equation. And then if I'm asking you to find the maximum product, maxes and mins happen at critical points. Critical points come from the first derivative. So you would probably want to multiply this out, and then you would have to do your derivative. And you do your derivative and set it equal to 0. So then we could solve from there. 5 equals 2x, so x is 2.5. So the first number is 2.5, and the second number, 5 minus 2.5, is 2.5. So at the end, if I'm giving you a word problem, how should you answer it? With a sentence. So I expect a sentence at the end, so you would say the two numbers are both 2.5 in this particular scenario. Right? So let's look at a problem. A farmer has 200 yards of fence to construct 3 sides of a rectangular pen. An existing long straight wall will form the 4th side. Okay, so we have some wall, and I'm building a fence off of that. So we only need fence on 3 sides. All right. We know it's a rectangle, so these sides are the same. I don't just want to call this one y, though, because what's wrong with that? Multiple variables. So we need to figure out what y is, so everything is in terms of the same variable. What information do we know? Yeah. That 200 yards is what? Yeah, it's our perimeter. If you add those up, it has to equal 200. So it's like saying x plus y equals 200. If I were putting it on all 4 sides, I would have 2x plus 2y equals 200. If I were putting a fence down the middle, it would be 3x plus y equals 200. So that's the amount of fence that we had to use. All right, so if I solve this for y, that tells me my y is 200 minus 2x. Okay, so this counts as identifying your variables. You can either tell me in words what they are or label it in a picture. Everything is in terms of one variable now. We don't have x's and y's anymore. What dimensions will maximize the area? So the thing you want to maximize, we need an equation for. How do you find area of a rectangle? Length times width. So that would be x times 200 minus 2x. If you distribute, that's 200x minus 2x squared. So there's my area. If I want to maximize it, what do we do? Critical points when the derivative is 0. So that's 4x. Critical points are anywhere the derivative is 0 or undefined. Would this ever be undefined? No, so we don't have to worry about that. So we get the x is 50. And now what? So x, those were the short sides. And the long side is, how would I find this side? If my x is 50, this is 200 minus 2 times 50. So we get 100 yards. So my fence, we have two 50-yard sides and one 100. Any questions on that one? I want you guys to read the next one and see if you can set up. I think I included some blank slides in here to give you guys a little more workspace if you need it. 1,000 yards of fence to build a rectangular corral. So we need the full rectangle. Some of the fencing will be used to construct two inner divider fences, both parallel to the same size. Alright, so if I'm labeling, if this is my x, all of these would be x. And these two sides would be my y. We have 1,000 meters, so if we add those up, that means 4x plus 2y equals 1,000. So if we subtract our 4x, divide by 2. So instead of y, we are going to call it 500 minus 2x. Are we okay with that? So we want to maximize the area. Does the area change if I have inner fences here? No, it's just the overall length times width. Minus 2x squared. So we do our derivative. Anytime I ask for a maximize or minimize, set it equal to 0. Okay, we need to answer the question. But I didn't ask you for the dimensions this time. What did I ask for? The maximum area. Now we do always kind of have to check. Sometimes, depending on our equation, we might get multiple answers. We need to make sure they're reasonable. If we are talking about building a fence, what would have to be true about the number you get for your side lengths? They still have to add 1,000, but what else? They have to be positives. Okay, so if you got a negative, we would know that didn't work. Or if I got my x to be 300, that seems reasonable. But what would happen if I plugged a 300 in here? That side would be negative. So you do have to watch there and make sure all of your sides are turning out positive. If I plug in my 125, what do we get for our y? 250. So those are all reasonable numbers. But I asked you for the area. So what do we do with those? So 125 times 250 is 31,250. Area will be square meters. So always make sure you are answering the question. Looked like we were doing pretty well on that one when I came around. Do you guys have any questions? Let's try something a little different. A piece of sheet metal is 5 feet wide and 8 feet long. So I have a piece of metal, 5 by 8. Congruent squares are to be cut from its 4 corners. So identical squares are coming out of every corner. The resulting piece of metal is to be folded and welded to form an open-topped box. So what happens is we cut off those corners and you're left with something that looks like this. And so then if you fold all of these tabs up, we create a box. Can you guys visualize that? So we have a rectangle, we cut off 4 corners. Looks like this. Fold on those dashed lines, you fold it up and you've got a box. This is actually a problem from college algebra. We did it back then when we were talking about quadratics and finding the maximum of a quadratic. Okay, we want to maximize volume this time. So do I know how big these squares were? No, I just know that they were all the same. So whatever their sides were, they're all identical. Good luck. Alright, so if this side was 8, and we came in and we took x off this end and x off this end, how big is it now? This side was 5, but I took x off here and x off here, so now it is. Okay, volume is length times width times height. I make my fold right here, so the height ends up being this. What's that measure? X. So my volume is x times 5 minus 2x times 8 minus 2x. So I definitely don't want to have to try to do the product rule 3 times here, so let's multiply it out. And if I FOIL these, that's a 40 distributed to x, so we get 40x minus 10 and minus 16, so minus 26 x squared plus 4x cubed. And again, I did volume because that's the thing I'm trying to maximize. So then if I want to maximize, what do we have to do? Derivative. So we get 40 minus 52x plus 12x squared. And we want to set that derivative to 0. Can I divide by anything? Yeah, let's go. I'm going to flip the order around too, so that would give me a 3x squared minus 13x plus 10. Now what? Flip and slide. or box method if you prefer that. So, whether you did slip and slide or box method, you should get x minus 1 times 3x minus 10. Set each of those to 0, and we get a positive 1 and a positive 10/3. So, right now it looks like we could have two different sized squares. Are both of those possible? Let's see. If I put in 1, then I would have 1 by, if I put in 1 here, that would be 3 by 6. So that's reasonable. If I put in 10/3, 5 minus 2 times 10/3, so that would be 5 minus 20/3, so 15 minus 20/3, which is a negative 5/3. Is that possible? No, we can't have a box with a negative side length. So the 10/3 is too big. That's like 3 1/3. If your side is only 5 long, you can't cut 3 off each end. So this question was, how should this be done? So we're looking at how big the square should be. So the sides of those squares should be 1 foot long in order to be able to create this box. Is that okay? We're going to do one more example for today, I think. So we're looking at some other applications here. All the ones we've talked about so far are kind of geometric, drawing a picture and labeling. But we've talked about some so far with cost and marginal cost. We know to get marginal cost, you do the derivative, and that tells you how your cost is changing at a particular time. So the marginal cost function is the derivative of the cost function. Another application has to do with marketing. So if P of X is your price at X units, your demand function or your price function, it should be going down. It's a decreasing function. So as you make more, as there's more available, your price would decrease per item. Revenue is price times quantity. The amount of money you bring in is the price you're charging times the number you sell. Okay, if I'm going to make pies and sell them for $25 each, the amount of money I bring in is 25 times how many pies I sell. Is that profit though? No, because what do I have to do to that revenue to figure out how much money I actually made? We have to subtract off the costs that I had. Okay, so revenue, price times quantity. If I'm talking about marginal revenue, that would be your derivative. Okay, marginal cost is your derivative of cost, marginal revenue is the derivative of revenue. Profit, it's not great notation, but typically in economics they do capital P for profit and lower P for price. So just kind of be aware of that. Your profit is your revenue, the amount of money you bring in, minus your cost, the amount of money you spend. So marginal profit would be what? Derivative. That's how your profit is changing. So let's look at a problem. Suppose the cost cost of publishing a book is $10,000 to set up the press run, plus $8 for each book printed. So that is our cost. Can we write an equation from that? You pay the $10,000 just to set up the press. Do you pay that multiple times? No, it's a one-time thing. Plus $8 for every book printed. What would I write? 8x. So x is going to be the number of books. Okay, so my cost is $10,000 plus $8 times each book. The publisher sold 7,000 copies last year for $13 each. The sales dropped to 5,000 copies this year when the price was raised to $15 per copy. Assume up to 10,000 copies can be printed in a single press run. How many copies should be printed, and what should be the selling price of each copy to maximize the year's profit? So I'm trying to maximize profit. And I know that profit is revenue minus cost. Okay? I have my cost, but I have to get a revenue function. Where could I get that? What is revenue in general? The amount of money we bring in. And we said that was x times p of x, right? So it's the number of books I sell times the price of each book. So I really need to find an equation for the price of my books. And then I'll be able to do that. Do we have any information about the price of our books? 7,000 copies when the price was $13. How would I write that? 5,000 copies when the price was $15. What am I giving you there? Ordered pairs. So to find my price, we know my X is the number of books, so 7,000 books, price is $13. 5,000 books, cost is the price is $15. So we can write our equation. We need our slope, y2 minus y1 over x2 minus x1. So the slope is negative 1 over 1,000. Plug into y equals mx plus b, so let's say I use the first point. That is my 7, my y-intercept is 20. So my price function is negative 1 over 1,000x plus 20. So I have cost. I now have price. How did we say we got revenue? Revenue is negative 1 over 1,000 x squared plus 20x. What are we trying to maximize? Profit. How did we say we found profit?
Minus the cost.
Revenue minus cost. revenue was negative 1 over 1,000 x squared plus 20x minus my original cost, which was 10,000 plus 8x. Future negative. So for our profit, we get negative 1 over 1,000 x squared plus 20x minus 8x would be a 12x minus 10,000. So here's my profit. Finally, all that work was just to get to the equation that I'm trying to maximize. How do we maximize or minimize? So if the 2 comes down, negative 2 over 1,000 or negative 1 over 500. Derivative of 12x would be 12, and we need to know when this would equal 0. Multiply over my negative 500. And we get 6,000. Remember, x was the number of books. So that means I will make my maximum profit when I produce 6,000 books. So that was the first question. How many copies? We need 6,000. I asked several questions here. How many copies should be printed? We answered that. And what should be the selling price? So remember, my price was right here. So to get the price for these books, I'm going to plug my 6,000 into that equation. Plus 20, is that right? So give me 6 plus 20 for 14. So if I want to make the most money I can out of this, I need to print 6,000 books and charge $14 each for them. Any questions on that one? So we are going to do some more problems tomorrow. This is our stopping point for today. So we are not ready to do all of these. I want you guys to do 3, 7, and 15.